And let me share my screen. As you all know, we are going to continue working through VPCs and networking today. We had an introduction to this on Monday when we learned about diagramming, and specifically we diagrammed some, well, we didn't diagram VPC resources, right? We looked at diagrams for VPC resources, but mostly focused on diagramming other things. Yesterday, let me actually make sure I share my screen here. How's everyone feeling so far about networking in AWS?
All right.
All right.
Networking in general for me has always been kind of difficult. Like I get the overall high level concepts, but sometimes when it gets down to the details, it gets a little, you know, difficult.
Okay. I agree. Yeah, some of the details can be really difficult. IP addresses, for example, are I think they're kind of challenging to talk through and explain, and it takes a while. It takes a while to like really get the hang of it. So we'll go slowly through those portions. And if I am going too fast, just let me know. So let's see. Right. Yesterday, you all covered. What did you cover yesterday? Oh, Route 53. Route 53 is external to VPCs, but it allows it works with VPCs. It's a way to route clients into the VPC. And today we're going to look more into the specifics of the private cloud and its components itself. So, like we saw on Monday with some of these diagrams, that's going to include things like, I don't like this. Grab my browser actually. Going to include things like a subnet, a routing table, an internet gateway. Maybe I'll just actually go straight into the console. So, right, if we go into our VPC view, we'll see that on the left-hand side, we have options to all of these configurations. Today, we're going to be reviewing subnets, route tables, and internet gateways. So let's go over a high-level explanation of what those things are. Okay. Okay, interesting. This starts with the router. As we discussed on Monday, if we were to have an analogy between physical local area networks and VPCs, routing tables are essentially the equivalent of a router in a physical network. And it works in conjunction with things like the internet gateway, which will be the entry point, and subnets, which are the reserved IP addresses that will determine where packets are routed to. So these four elements are essentially what we're going to want to configure inside of a VPC. The subnets, so we know what IP address ranges can be distributed to both the server components and to clients trying to connect. And the routing table, so that we can actually route these different entities through these different subnets. And again, the internet gateway, because that's just the entry point. And if we have, a lot of this is very high level. I would say read through this. I'm not going to like read through this right now. I'm just going to talk through all of it the way that I've been talking about it before. I think this will give you like some more granular detail. So definitely use this first lesson as additional reading. We're mostly going to be demoing all of this in the AWS console with the second lesson. And the challenge for today will also follow that same flow. So, right, a lot of this sounds familiar, or is essentially along the same lines of what I've been saying just now and on Monday. Uh, an internet gateway is a necessary component of any VPC that needs to connect to the internet. It provides connection between your VPC and the internet. Essentially, like I said, it's your entry point. It's a gateway. We all know by now security groups are essentially critical to anything EC2 related. The security groups are what allow for the authentication of various entities. So essentially, it acts like a virtual firewall for your instances, and it can be associated with multiple instances. As we've seen by now, when we go to create an EC2 resource, we're asked if we want to use an existing security group or if we want to create a new one. And within that security group, we're able to allow inbound and outbound rules. And the more and more you do this, the more familiar you'll get with what might seem like arbitrary um, associations at first, right? Like port 80 is always associated with SSH. Um, HTTP, HTTPS have like their own designated ports. And over time, through repetition, you'll just get a hang for what those values are. And even if not, it's not the most important thing to memorize, right? Because when you're going into the console and making a resource, you'll be able to see a lot of these details anyway. So let's scroll back down to the security group rules. And we could see, for example, if we were to edit this, our SSH policy is set to 22. And if I add a new one for, I said 80 earlier, didn't I? I was wrong. I meant 22 apparently. And 80 should be for your HTTP. Let's see. Yeah, 80 for HTTP, and I think 443 for HTTPS. Again, not the most important thing to have memorized. Not only will these be available in the console, but it's an easy Google search. I think what was it? What was Einstein's quote on memorization or something? Like, didn't he say something along the lines of he doesn't bother memorizing anything that he could just look up? All right, let's
You
see.
didn't even memorize it.
What was that?
I said you didn't even memorize the quote about memorization. So you could look, we could just look it up.
Why bother memorizing quotes when you can just look them up? Okay, this is how security groups fit into instances, or it's at least a very crude representation of how that happens. And yeah, this is a very crude graph, but I guess you have connections coming in from either public or private networks into an instance, and the security group is going to dictate whether or not that traffic can pass through. So it does that through things like the port number that it's assigned to various IP ranges, and the entities connecting themselves have to um, fall within an IP range that has been specified or allowed. We'll briefly talk about network access control lists later on as well, just so you could see what these look like in comparison to internet gateways. But it's essentially another entry point or another form of entry point. So in AWS, a network access control list is a set of rules that controls traffic flow. And each rule in an ACL specifies a protocol. I think we'll cover NA's, not network access control lists again in a week or two, and we should be taking a deeper look at how these compare to security groups, right? Because we already know you have a layer of security at the security group level. So there's the security group that's filtering for certain permissions, right? The network access control list is a separate layer. So you could have multiple layers of security in place, and that can both work in your favor or backfire, right? Because a complicated or an overcomplicated configuration, I should say, may not even be providing the value that, I don't know, stakeholders might think it would be, right? If it's causing a team or an organization more trouble than it's worth, then it's probably over-engineered. But of course, all of that's going to vary um, per organization, right? Like different organizations, different companies are going to have different use cases for whatever software they're maintaining and operating. So the key thing to know here is it's just another layer of security. Here we could actually see that, right, it's acting as a layer of security between the subnet itself and the router. And if we were to try and throw the security groups in here somewhere, they would probably connect beyond this router, and the instance that it's going to would be above that. ACLs can be implemented in hardware like a router or firewall, or in software like in AWS. Elastic IP, wow, there's actually a lot of this is a really broad overview. Like we're not even going to be covering elastic IPs for a while, but this is basically a static IP address that you assign to your resources. The way that we've been using EC2s right now, we have the public IPs assigned by default. That's what we've been selecting. So, right, it allows you to assign a fixed public IP address to a resource so that it can be accessed. And then we have a network address translator. And this is, there are two that AWS provides, a gateway and an instance. And the gateway is a managed service that provides internet access within a private subnet. I think we'll configure this later on today too. It will automatically scale to meet the needs of your application, and it's highly available and resilient. We are not going to spend too much time on this today. Again, this is just kind of like exposure to the NAT, and you'll cover this more in future weeks. The things that we do want to focus on today are going to be the VPC, subnets, route table, and internet gateway. So let's switch over to the next lesson. And actually, I'm going to switch over to the README because I updated the README just like 10 minutes ago. I don't like that. It's just kind of like these long lists of steps that are painful to read through. So I broke it down a little more granularly. And let's go to our curriculum. And let's go to this week, week 5, day 3, and the updated lesson. Okay, so now we have slightly shorter lists, and they have little headers to tell us what we're trying to do exactly. So let's see if we could do something like this. Follow along if you, well, just follow along. You should have AWS pulled up right now and should be able to run through this as I am. And we're going to start by creating a VPC. So let's go over to a region. Let's select VPC. You could either search for it if you don't have it bookmarked, or access it through your bookmarks, or pins, I guess. I don't know what they're actually called, but here we are at our VPC. You could see what VPCs currently exist. I've already created one for the demo, so we could use this as a reference if for whatever reason this next demo fails or we hit any kind of obstacles or hiccups. But let's also just create a new one from scratch. So I'm gonna name mine W5D3 VPC2. Very creative. Okay. I'm also going to select an IPv4 range, and this is what I was alluding to earlier. One of the things that I hate trying to have to explain. Does anybody here feel very confident about like IPv4 addresses?
Very confident in what way? Like I know when I look at one if it's private or public, but other than that, I mean,
Um, yeah, like you want to take a stab at explaining the different components of it?
um, I don't know what that. I know looking at that 10 whatever. Like no, I don't feel very confident actually explaining. I just know like every time I have to find one, I just have my resources that I use to I guess figure out at work if it makes any sense. But I can't explain
Okay,
IPv4
okay.
Yes, you can. Yes, you can.
addresses. 192 private
Yes.
or 172. One of them is one of them private. I think they both might be,
We'll
but
we'll get to
yeah.
that point, and like I think one of the reasons that's so difficult to explain is because those designations are kind of very arbitrary, right? Like it takes a lot of like really in-depth, nuanced knowledge, including how, or maybe even like the history of the protocols that define this, right? Because otherwise it does seem arbitrary. Why 172? Why 192? But let's rewind. Let's start very simple and talk about like these two halves of it as specific components. This first, these first four numbers are your, well, that's your IP. It is four sets of octets, which are basically 8-digit representations of bytes. And so when you have a number like 10.0.0.0, that's a representation of like these four different octets. And the number on the right is your it it's your subnet. And basically it's going to be the number that determines how much of your IP range is reserved for server-side connections or private addresses. And the remainder of that will be used for public IPs. So if we had, for example, 10.0.0.0 forward slash 16, this would give us more available IP addresses, public IP addresses, than would 28. And when we get to the subnets, we'll actually be able to see this a little better because AWS's console will show us like a little number and like an explanation of what valid IP ranges we could provide. But for now, that's as best of an overview as I could give from the top of my head. We'll go over it a bit more in more detail and like maybe correct anything that could be explained better as we go. But for now, we are going to go ahead and select this default .0.0.0.024, whatever it was recommending. This should give us, if I remember correctly, 256 available IP addresses.
And there are also calculators online for that.
Yes, there are. But let's take a look at those after the subnets so we can start to actually have a little more context to play with before going to the calculators. Cool. Tenancy, I don't really even know if I need to explain this, but you have a little info block here that will let you know that you could run your VPC on single tenant dedicated hardware, or you could just set it to default. And it will ensure that instances launched in this VPC use a tenancy that's attributed at the launch of that instance. Tags. Tags are, as you already know, associated with things like the name. You can use it to search for the resource. I like to have consistent tagging between everything that's interconnected when I'm setting something up. So this will continue to use the W5D3-VPC2 tag. And now I can create my VPC. It is available and it's good to go. And from here, we're gonna work on creating some subnets. Oh, before we do that, whenever, well, within AWS account, there's always going to start off a default VPC. So I'm sure by now you've already noticed this VPC. I think you might have interacted with it at least once or twice. This was the VPC that was set up when this account was set up. Yes, Flo?
Sorry to interrupt. I just got an error saying there was, or the maximum number of VPCs has been reached. Did anybody else get that?
Are you guys all on the same account still?
Yeah, I got the same error.
What region are you on?
I'm in
North
Virginia.
Okay, can you all try, yeah, Ohio East 2? And then I'll delete these after the demo, so could free up a few more here. So
Thank you.
you might have to work in groups then if there's going to be like a limitation of 3 per region. So we'll work through that. But for now, try US East 2 or US West 2. Those two should still be available. I think Chandra blocked off, I know he blocked off US West 1 for EC2s. I don't know if he did for VPCs as well, but if he blocked it off for EC2s because it's a little more expensive, then let's try to avoid using that even for VPCs. Okay. Right. We have the default VPC, which you're welcome to use, but for the purposes of today's lesson, we are creating a custom VPC. And so I've made my new VPC. Now I can start to configure some subnets. The default VPC had some created for it already, but if we grab our new VPC ID, we'll see that we don't have any subnets for it. I'm doing Command F to find this ID and nothing's turning up. Similarly, I could go to the VPC resource itself, scroll down to its resource map, and see here that there's also no associated subnets. So let's go ahead and create some. We hit create subnet. We select the VPC we want to create it for. So we want to create for VPC2. It's going to show us what the VPC's associated CIDR range is. And then here we could name our subnet resources. So VPC2 subnet 1. I'm just going to leave that as no preference. It's going to go ahead and select one of those. And here is what I was referring to earlier. If I were to do something like this, it lets me know that I've got 256 IP addresses available on this subnet. So let's go ahead and create this. Keep in mind, notice how these match, right? Basically, this is choosing the IP range for the subnet. And then we're also saying we want to use that IP range for this subnet. Okay, so now let's create this. And in our demo today, we are supposed to be creating both a public and a private subnet. So I'm gonna maybe think about this as being my public one, and I'm gonna create a new one to use as my private one. Oh, I didn't copy paste it. Whoops. What was it? VPC subnet 2. And now if I want to create a second one, I am going to run into this issue. If I try to create it again, it's going to let me know that it overlaps with an existing subnet. Basically, I've used up all of the IPs that I've made available in the VPC with my first subnet. So now I can't make a second subnet. So what do? You can't go back to your first one and just change it. You'll have to recreate it completely. So let's go ahead and do that. I'm going to delete the subnet. I'm going to type delete. And I'm going to create another subnet. And I keep forgetting to copy paste it. 5, 3, and type VPC subnet 1. And this time, instead of using 24, which uses up all 256 IPs, I'm going to give it a number like 28. Notice how the available IPs diminished as that number increased, right? So it's kind of like an inverse relationship, because this number represents how much of the IP range is reserved for the private resources and how much are available to public resources. So we want to use a smaller number, basically. I'm going to use 28, which means I'm only going to use 16 IP addresses of the, or I'm going to only allow the usage of 16 IP addresses from the 256 made available to the VPC. Okay, I'm going to go ahead and create that. Now I can finally create an additional subnet. And we are gonna try this again, and we might run into a similar issue, and we'll talk about why. So again, you can't just use the exact same range as the previous subnet because those IPs have already been reserved. And this part is where I'm a little iffy on how to explain it, but going back to the idea of these first 4 numbers as being octets and representations of bits, if we know that there are like 16 IP addresses already being reserved for our first subnet, we could simply update this to 16. And now we're going to be utilizing the following 16 IP addresses. Does that make sense? Let's see how handy this is. Okay.
Julius, what was the CIDR block that you chose for the second subnet?
Sure.
I missed that part. You clicked through it pretty fast. So
Sure. Yeah, my bad. Let me go back to that. So let me refresh here and let me explain that one more time.
thank you.
Yeah. So it's 10.0.0.16, right? And let me show you by creating another one why that is. So let me create a third VPC subnet. I'm going to select my VPC. I'm going to name it number 3, availability zone. I don't care about that. And now if I try to go to that one that I did before.
So when you first created your, what was that? What is it? Subnets? Is it like I don't know. is this supposed to be some sort of like logically blocked off? So when you first created the first subnet, that's the first 16. So then you put 0.16 at the end, at the third zero place, and then that's starting from that 16 after that. Okay. Cool.
Yeah, exactly. So if I were to try this, it's going to let me know that I can't do that because it's already being used by another subnet. So I could do 32, and if I were to try 31, it should stop me from doing this. Yeah, because there's still an overlap with the previous 16. So now if I do 32, it's going to be good to go. Oh, cool, and automatically update. So it will complain if there's an overlap. And once you're past that overlap, it'll let you know that you can submit. So that's in a nutshell how one way to use the UI and the AWS console to kind of help you configure your subnet addresses. And basically, when you go to create your VPC and you're setting that first uh, CIDR range, it kind of just makes sense to start at the very start of that, right? Like it doesn't make sense really to have created my first subnet at like 32. Sure, the first 32 would still be available, but that just might make it a little harder for me and my team to track what is available and what isn't later on, right? So just try to be linear and chronological about it. Unless you are very confident in deviating from that and you have your good reasons to do that. Okay, so that's in a nutshell IPv4 ranges, and maybe we could take a look at this one more time just to see if any of this is helpful. So we talked about how each of the four numbers are 8-bit octets. And so if we were to convert this into binary, that's kind of like, this is what it would look like. So this is conversion between our decimal value and what it looks like to a computer. And then the CIDR notation at the end, this is what splits the IPs beforehand. And we have our network bits, which is reserved for the network, and then the host bits, which will be available to devices that are trying to connect. So you have your server and your client, basically. Network basically represents anything that's reserved server side, and then hosts are external connections, so clients in this case. And because this number represents the first part of this, again, the larger that number, the less remaining bits available to the hosts. And the math behind it is all beyond my ability to articulate right now. So that's just a very high level kind of explanation of that. So a 16 gives more flexibility to connect because it gives you more host bits, while a 24 will reserve more of those bits for the network itself, leaving fewer for external devices. Okay. And then you could find cheat sheets and stuff online and calculators like Paige mentioned. So all of that is available to help you make more informed decisions when you really need that level of specificity. For the sake of today's example, and really the bulk of what we do here during the cohort, if you're just using like reasonable amounts of IPs, like reserving 256, like that's already way more than we'll need for any of the systems that we create and set up. So this is all good to know. I don't know how much of it you'll retain a month from now, 2 months from now, 3 months from now. Boils down to your eventual use case and what area of engineering you go into. But that should help you at least get through what we need to get through, and that's configuring subnets and VPCs. Cool. So that is part two. We've created our subnets, and now we can go and create an internet gateway. There may or may not be a limit on these as well. There's not a lot of configuration for this either, so I might just use the one I've already created. No, I'll create another one. And if it gives us any complaints, then we'll adjust from there. So now we want to do W5D3, VP, what is this? No, Internet Gateway. It might be Gateway 2 because I've already made one. Okay, yeah, see, like I said, nothing to really configure. We're just going to go ahead and create it. And even in this screen, we see that there's not a lot to look at. One thing to notice is it's going to start off in a detached state. It's not connected to anything. Once it's created, we want to attach it to something. And so if you remember that view we had inside of VPCs, that we looked at the other day and today, it shows subnets, route tables, and network connections. Is this the new one? Oh, this is already connected to a route table. Route table is this. Did I name it the same thing? Or I'm sorry, I'm having a brain fart. We're talking about internet gateways. All right, so it's not connected to an internet gateway yet. So I got to connect to an internet gateway. And where were we? So we want to go to the internet gateway itself, go to what we created, which I think in my case is this. This one's detached. And so I want to go to actions and attach it to a VPC. And I'm going to select my VPC and I'm going to attach it. Now it's attached. Now, if we go back to the VPC and we go back to that view, we'll see that it is connected. Okay, but we're not done yet. Now we have to connect the route table to the internet gateway. So let's go over to our route tables. Let's select, let me think, hold on. When I made the subnets, did I specify what route tables to go to? I made W5D3, subnet 2. This is attached to my VPC. Okay, it's not attached to a route table. So I haven't created a route table yet. I'm trying to like think of what it was that associated with a route table. It might be some of the naming convention that I'm using. I might be like reusing a name somewhere. But let's go ahead and create a new route table anyway. I'm going to select my VPC2. I'm going to call it route table 2. Okay, so I've created a route table, and now I want to click on the route table and edit some routes. Let's do that. I'm going to add a route. I'm going to select this destination of 0.0.0.0. Basically, this is saying we can route traffic, exiting traffic to anywhere. And let's connect this to our internet gateway. And we're going to select the one that we just created. And that should be all I want for now. So I'm going to hit save.
Oh, you're going a little too fast, Julius. I'm like so lost.
Oh, I'm sorry. All right, where are you?
The editing routes. I think.
Okay, editing routes. Okay, so you're at your route table, right?
So when you said like select a route table on that chart, I don't see anything to click on.
Okay. When we click on route tables here, do you not see a route table?
So I'm at the route table, the one where it says edit routes.
Hmm.
Okay, so there's nothing to click on there. Okay. So you
Okay.
just click edit routes.
Yeah.
Okay. Yeah, I'm there.
Okay. So I hit edit routes, and this is where I route this route table to my internet gateway.
Yeah, so over on the left side, I just have route one. And do I just click add route? So I just click
Yes. Yes.
add
Yes.
route, and then my destination is at 00,
Hmm.
and then the target is gonna be
Yeah, the internet gateway.
okay.
We saw in the README that we have other gateways, so that's what this list is. So let's just select from a list of gateways what we want to use. We've only created internet gateway, so it's the only one that we really should be picking right now. Okay. So I don't want that. I'm going to remove it and hit save. Man, and I guess I didn't make any changes. So
So that's
next,
all I have to do, just the internet gateway, and then underneath it, the gateway serial.
yep,
That's it.
yes, yeah, exactly. Select the one
Okay.
that you made.
Okay, I did that.
Cool. So now that we've connected the route table to the internet gateway, oops, I don't want to do that. And if we go back to the VPC view, we'll see that it should be connected in that view that we kept talking about. So, right. I don't know if all of yours is connecting to like some route table. Mine seems to have created some default route table that it's connecting to. But what we want is we want this to connect to the one we just created, right? So we have to connect the subnets to the route table now. And so if we go to our subnets and we go to, there's actually a few ways to go about this. Like I'll show you this part first, and then we'll go back and look at how to do it another way. I think the ones I created, yeah, I'm definitely getting mixed up with my naming convention. I don't know which is for this new demo and which is from earlier. Um, let's see. Oh, one way I could be sure is to look at the VPC that it's associated with. All right, demo-VPC is the old one. So what I want to look at is, let's look at this. It's the first new subnet that I made for this current demo. Now, if I click on my subnet that I want to connect, it's going to show us all of this. I'm going to scroll down and I'm going to select the route.
Julius, like the subnets, I made multiple subnets. Like, which one should I click on?
Let's start with the first one. Yeah. For the demo, we're going to use the first one for a public route, and then we'll create a private route for the second one. Okay, so I've selected my first subnet, and I see that it is associated with a route table, and it's only got one route. I want to connect this to the new internet gateway through the route table that I created, right? So yes, this is a default route. That's not what I want to use. I'm going to change it to my new one. And we know this is my new one because I tagged it. And once you select your new route table, that should be all you need to do. Now you could hit save. And if we go back to our VPC and we go back to that view, we'll see that we have one route table, or sorry, one subnet going to our new route table, going to our internet gateway. And that should be all you need for the public associations. Okay, let me know if anyone's not there yet. Okay. So we want to test this now, right? We want to see if we can actually connect to this from an external location. So in order to do that, we have to create an instance that we could actually test. So first, let's go ahead and go back to EC2. I'm gonna launch a new instance. I'm going to name it something that hopefully doesn't confuse me. EC2 demo 2, it's a little more clear. I'm gonna select an image. I'm just gonna use this default one. And I'm also just gonna switch to nano just because it's a little cheaper. And we don't really need to do a lot with it other than test a web server, a very simple web server. I'm gonna select one of these. And I want to edit my network settings because right now by default, it's got permissions for SSH enabled, but I want to be able to test this for my browser. So I'm going to add another security group rule, and I'm going to do it for an HTTP connection. And that will default to port 80. I'm just going to go ahead, choose this block that specifies that any traffic will be allowed. And that should be most of what I want. I want to check one more thing, actually. I want to make sure that auto assign public IP is enabled because I want to try to test this from my browser. So we need that public IP in order to access it. So with those three things, basically tags, your security group settings, and your public IP enabled, you should be good to go.
Real quick, Julius. No, never mind.
Sure.
I was
Okay.
just going to ask if you were supposed to select VPC
Oh,
or point.
yes, yes, yes.
It
So
was
this,
actually more of a question, but then I saw the error.
yes. So I forgot to check my VPC, and this is why I'm seeing this. So let's go back and fix that. I need to go to where it asks me to select my VPC.
Network setting.
Yeah, there we go. And I don't want the default one. I'm going to select the one that I created. All right, cool. So now it's also going to complain about this being invalid for this VPC. So let's see. I'll just create a new one, and then I'll be sure to go through and clean up all of this later on. I don't want that. Go ahead and create. W5D3 to G. I have SSH enabled. Okay, cool. At least it's saved these configurations from before. And now I want to double check auto assign public IP. I'm going to enable that. And now with those four things selected and configured correctly, I'm going to launch my instance. What? Okay, what's going on here? On US East 1.
Oh, you don't have permissions to do it?
Are you all getting this too? I mean, I just created one earlier when I was running through this. I don't know what's going on this time.
Yeah, I'm getting it too.
I wonder if we have, I don't think it's a limit though, because this, let me see. Let me just run through everything, make sure I'm not forgetting anything else. I'm on US East 1. Selected this. I selected VPC. Selected the public subnet on my VPC. Oh, okay, let's see. created the new security group. Now, let me compare this to my other. Yeah, that's weird. So yeah, this is one of the things I was troubleshooting earlier also. But selecting my VPC was enough to like let me get past this earlier. If we look at IAM, and what this is, at least for me, is a restriction where we made sure that we would have any EC2 requests denied if it wasn't in one of these regions. So it's an explicit deny permission, and the condition that applies to it is if the selected region does not equal one of these.
Changed my security group and it worked.
Okay. What did you change it to?
It's had two selected.
Oh, it did.
I don't know if I did that or yeah, there's default and then there's launch wizard. And I switched mine to default.
Oh, you selected the default. So you just selected.
Yes.
Okay, I'm gonna try that. Even though the security group is associated with a different VPC. Okay.
Mine worked. I also changed mine to micro. I don't know if that does anything.
Oh, that shouldn't matter.
And is there a reason why you're using Amazon instead of Ubuntu on yours?
No, it's just the default one. I just
Hey,
left.
Julius.
Yeah.
Based off of what Jeremy said, I switched my nano to micro, and it ended up working out for me.
Oh, really?
So I don't know if there's like a restriction on using nano.
And oh, yeah. Free tier eligible. Okay, yeah. Good call, everyone. I did not even notice the free tier eligible comment when I switched to Nano earlier. And I probably forgot to switch it to Nano when I tried again, and that's why it worked with my first demo. So let's see if this works. I'm having my security group. I'm got that enabled. I've got the right VPC and subnet selected. So I'm gonna go ahead and launch my instance. And it works. Cool. So now that my EC2 is up, we're gonna go ahead and SSH into our EC2 and just set up a very simple web server. Where is, okay, I'm like, this is mine, right? EC2A? Yeah, EC2A. So I'm gonna grab my connection URL. I'm gonna switch back to VS Code. I'm gonna open up a new terminal. I'm gonna go to my SSH directory. This is where I have all my keys stored. And the one I selected was CP class students, so I should be good to go to use that. Okay, I'm on my EC2. You all should already have instructions on how to set up a web server from like at least one of the challenges or assignments. Like we've done that a few times. I left mine at AWS 2023, and so I'm just going to run these commands wherever I have them pasted. So, okay, for this AMI, I'm gonna first update my package manager. It's already good to go. I am going to install Apache. So if you want to just follow like maybe the example from one of the LAMP stack readmes, that should work fine. As long as you have some kind of web server, you'll be able to test this. So I'm installing Apache. It's good to go. I'm gonna go ahead and start the HTTP daemon, and I'm gonna see if it's well, this step's not super necessary, but I'm gonna now make sure that it's running. All right, so I checking my status. It's listening on port 80. That's the HTTP port, so it should be good. And now if I go back to my EC2 and I go to my public address, I'm going to click on this. I'm going to make sure I'm connecting via HTTP, and I confirm that it works. I am able to hit this EC2. It is correctly routed to an internet gateway, and it is using the route table and subnets that we had configured earlier.
Can you just go back and show what you installed on your EC2 instance before you got there?
Sure. Okay, so if you remember from the LAMP stack, we ran through that twice, installing Apache on an Ubuntu image, and then we installed it again on an AWS Linux image. This is AWS 2023 or Amazon Linux 2023. And so it wants the HTTPD package. If you selected this, if you happen to select this image, I'll just copy paste these commands into Zoom. So, let's see. This is,
Anybody have the links to those for Ubuntu commands? I don't know what to put in there.
oh yeah, for Ubuntu, let's see. When did we cover the LAMP stack? Oh yeah, should be this. Okay, I'm gonna drop this off inside the Zoom chat too. Okay, because the first part is for Ubuntu 22. And I think there's also instructions for Amazon Linux 2 at the bottom. And I'll finish copy pasting these just in case you left it at Amazon 2023. So that's all Apache. Starting. Checking the status.
After you install Apache, how are you supposed to check? I'm lost. Like after you install Apache, what are you supposed to do?
Once you install Apache, all you have to do is make sure that the daemon is running. So like it's actually serving the content. That's all Apache does. It's basically going to be a service that runs on the machine, and it makes sure that it's serving some HTML content. And once that's running, like your status says it's good to go, you could go back to your EC2 and you could grab the EC2's public IP address, because that's the address that the Apache server is going to be serving to. So if I click on my EC2 and I go to open address, It's by default, I think, if you're using Chrome at least, it's going to default to an HTTPS URL. And if you remember when we were setting up our security group rules, we only enabled a security group permission for port 80, which is HTTP. So if I delete HTTPS and I try to connect through an HTTP protocol, I should be also, if we go back to my terminal and where I ask for the status, it tells me that it's listening on port 80. Okay. So last week, you all walked through how to deploy some applications on EC2. If you have like containerized applications running on that EC2, you could run things like Django React application, or even some of the simple stuff that we have, like the Dojo jump. And with a web server running on that EC2 and configurations through the VPC, your application is now open to the public, as long as they're hitting the right address. And then from here, you could use things like Route 53, I think, to map it to a URL. There are other ways, like through cloud. It's CloudFormation, CloudGate, blanking on which one it is. But this is essentially how you get your app available to the World Wide Web. Okay, the other part of this was setting up a private IP. It's essentially the same thing. There's two ways to go about it. I'm going to show you the less secure way to go about it. And so if we go back to our internet gateway, which one did I make? Is it? No, sorry. We want to go back to our route table. So route table 2. And if we go to edit routes, I can do something. I want to select a range that's not already being used by that first route. I want to then select, what did I select before? I'm going to try local. No. Oh, I'm going to try a NAT gateway. Okay, so let's say we wanted to create a private subnet as well, right? We could either create an entirely new route table and dedicate it to private resources, which is the more appropriate thing to do. Or we could do it this way, which has a little fewer layers of security to prevent cross traffic. And just for demonstration purposes, this is what we're going to do. I think I've already made my NAT, but if in case you haven't, this is how we're going to do that. We're going to go back to VPC. I'm going to go to NAT. We're going to create a NAT gateway. I'm just going to use the one that I created. Actually, no, but yeah. I'll at least talk through how to create a new one. So like you name it, whatever you want, NAT gateway 2. And then you select your second subnet because that first one's already been routed, right? So for me, it's W5D3 subnet 2, I think. And then I want this to be a private connection. It's going to tell me that NAT gateway traffic can't reach the internet, which is what I want. And I'm going to create it. Once it's created, then I go back to my route table and I just select that NAT gateway. I might have to refresh. Why is it not finding it?
Julius, maybe do you have to select the 00032?
I thought I had it selected before. Are you all able to see your NAT gateways?
Yes.
Okay. Maybe I'm editing the wrong route table? No, this is the right route table. Did I not tag this? Or I didn't create it, right? Or did I? Okay, no, I didn't, and I did tag it. Let me just see if I could just grab this then. I didn't accidentally switch regions. Okay, I'm gonna see if it accepts that. They belong to different networks. Yeah, this might just be where all my wonky naming conventions are getting the best of me. Every network interface. VP. Okay, I selected the first. Yeah, I selected the wrong VPC for this. So that means I selected the wrong subnet because my naming conventions are terrible. So let me see. Let me just double check, make sure I have the right subnet name, which is connected to my VPC2. So it should be, right, it should be one of these. So I'm gonna make sure I select the right subnet. -2. Oh, I want it to be private. Well, that should be good. And now it's associated with the right VPC. So if I go to my route table and add a new route, and I select Net Gateway, it's now available. So in order for the gateway to be visible to your route table, it has to be associated with the same VPC. And again, I'm going to select an IP range that hasn't been used yet. And I'm going to save my changes. And if we were to run the same steps, like if we were to go to EC2, create an EC2, toss it into this associated with this private subnet and try to access it from the public, it should block us from doing that. So let's just see if EC2 4, go run through all of this again. Yeah. Can't wait till we get to Terraform. Won't have to deal with the UI anymore. All right, let's see. So if we, all right, make sure I have the right VPC selected. VPC2, and I'm using the free tier eligible micro. I want to make sure this is associated with my second subnet now, which is the private one. Let's enable this anyway. Maybe just select the same security group. No, not make a new one. For HTTP. I think that's everything. I'm gonna launch my instance. Almost everything. And then I'm gonna do exactly what I did before. I'm gonna try to SSH onto it. Except I can't because it's not public. So my configuration is working just as I had configured. It is associated with a NAT gateway that prevents any kind of public access. So I can't SSH onto it, even though you saw the security group permission was set. And I can't, obviously, I won't be able to access it from a browser either because I can't even SSH onto it to set up an application. So that is how to set up both a public and private subnet.